Hello my dear students, welcome to Deeksha Karnataka YouTube channel, and in the rapid revision series today I am going to discuss another important chapter, current electricity, and this chapter is very important for your board exam, and from this chapter you are going to expect at least 13 marks in your final exam. So let's review this chapter and quickly revise it in under 20 minutes. And even though the chapter is very important, there are very few concepts in this chapter, so it will not take much time. So even I am expecting it to complete within less than 20 minutes. Okay. So let's see what are all the topics that we are going to discuss. Electric current, Ohm's law, resistance and resistivity, drift velocity, combination of cells, Kirchhoff's laws, and Wheatstone bridge. Okay, mostly a formula based chapter. Derivations of the formulas and problems based on the formulas are very important. If you want a detailed explanation of the chapter, you can check master stroke. There I have explained everything in detail along with the problems, and if you want to practice some questions from this chapter, then definitely you should look for our Brahmastra, where I have solved question from this chapter. Now if you have any concept related doubts, conceptual problems, and if you want to revise the chapter quickly, then this is the video for you. Also I request you, don't forget to subscribe to our channel and join the WhatsApp channel if you want to download this PDF along with all the other PDFs that we have done in our channel. So let's start. First we will start with electric current, as obvious as that. So the net amount of charge small q flowing across the area in the forward direction in the time interval t, then the current is given by, what is current? Suppose we have a conductor through which we are allowed to flow some current. Then what is the current? Suppose we have a small amount of charge which is passing through this area in time t, then the current is given by I equals to Q by T. Obviously we all know that this is a very simple definition, and we are studying it from our class 6 class 7 standard, right? Currents are not always steady. So now we are in the second PU, so we have to improve on this definition, right? So current is not always steady. Okay, that means current is not always constant. Current fluctuates with time. For example, AC current is not at all constant. It is varying with time every second. But even in case of DC current also, it can reduce, it can increase, decrease based on the different cases. So hence, more generally, we define current as follows. So current is basically defined as limit delta t tends to 0, delta q divided by delta t, and what is this? This is nothing but dq by dt. So this is the higher order definition, your second PU level definition. So current is given by dq by dt. Okay, so in some problem, suppose charge q is given in terms of time t, and they will ask you what is the current after 2 seconds, then you just need to differentiate it, put t equals to 2 and solve the answer, right? Now let's move on to electric currents in conductors. Obviously conductors are required for electric current to pass. Electric charges experiences a force in the presence of external field. So this is the force we called basically Coulomb force, and that force is given by Q into E, right? We have studied this in our electric charges and field chapter. Electrons being negatively charged move opposite to the direction of electric field. Now if this is a positive charge, it moves in the direction of the field. If this is a negative charge, it moves in the opposite direction of the electric field. So obviously electrons are negatively charged, so they will move in the opposite direction of the applied electric field. So if this is the electric field, then the electron moves in the direction opposite to that of the electric field, right? Now metals have a large number of free electrons. Obviously metals basically consists of a large number of free electrons. Why so? Because electrons are basically in the conduction band for metals, and they are allowed to move within the metal freely. They are not allowed to leave the metal, but they can move freely within the metal. Okay, these electrons accelerate in the presence of external electric field. So suppose you have a conductor, and if you apply an electric field in the conductor, then the electrons basically starts to accelerate in the presence of this external electric field. Okay, this gives rise to the electric current. So electrons are accelerating in the opposite direction, and that gives the electric current. Okay, now generally electric direction of electric current is taken in the direction of the applied electric field. So current is basically in the direction of applied electric field. Electrons move in the opposite direction of the applied electric field. These are all basic things. Now let's move on to the law which governs the charge, the current, voltage, etc. So obviously that is Ohm's law. So if temperature and other physical conditions remain same, the current I through a conductor is directly proportional to the potential difference. So V is proportional to I, or I is proportional to V. Okay, if X is proportional to Y, Y can also be written as proportional to I. X, right? So from there we have written V is proportional to I, or V equals to IR. R is the constant of proportionality. The constant of proportionality R is called the resistance of the conductor. The resistance R not only depends on the material of the conductor but also on the dimensions of the conductor. Okay, so it not only depends on the material of the conductor, it also depends on the dimension of the conductor. Now if you plot a graph where you increase voltage and correspondingly if you measure the current that is passing through the conductor, then the graph that you will get, it will be a straight line passing through the origin. It will be a straight line passing through the origin. So at 0 voltage, 0 current should pass, and as you are increasing the voltage, current is increasing, and the ideal conductor should always give you a straight line graph. Right, now Ohm's law, this is the common form of Ohm's law, but there is one more form of Ohm's law which is in vector notation, which given by J is equal to sigma E. What is J? J is current density. Current density, so magnitude of J is I upon A. Okay, and sigma is conductivity of the conductor, E is electric field that you applied. Okay, so this is the alternate form or the second form of Ohm's law, vector form of Ohm's law. So everything is same. So suppose we are familiar with vector form of Coulomb's law, but if they ask you write vector form of Ohm's law, then all of you may be confused, right? So that means vector form of Ohm's law is this. This is the vector form. Just for your knowledge, you should also remember this. Now let's move on to resistance and resistivity. So we are talking about resistance. So resistance depends on the dimension. How it depends? Resistance depends on the length of a conductor. So if the conductor is lengthier, resistance is more. You can imagine that you are driving a car in a highway. Okay, you are driving a car in a highway. Longer the highway, longer the distance, it will take more time for you to reach to the other junction, right? And based on more number of, if there are more number of cars present in the highway, you have to navigate your cars through between the trucks and lorries and everything, and between that you will be slowed down and it will take a longer time to reach to the other end. Now resistance is inversely proportional to the area. So you can consider that the same highway where you are driving, okay, is very wide. If the highway is very wide, even though there are a lot of trucks and lorries, you can easily navigate through them because the highway is very wide and you can easily take a side and you can move along the road, right? So wider the wire, easier for electrons to navigate through other electrons which are basically acting as lorries and trucks present in the highway. Okay, it is easier for the electrons to navigate through it, and it experiences less resistance. Resistance means the material of the conductor tries to stop that electron from fleeing, from moving. Okay, and that is basically resistance, right? Resistance is very common term. And resistance, in if you remove the proportionality symbol, you can write resistance equals to rho L upon A. What is rho? Rho is called resistivity of the conductor. Rho is called resistivity of the conductor. It depends on the material. Okay, resistivity is independent of geometry of the conductor. It varies from material to material. Okay, and with temperature. So resistivity is a constant for a given material at a given temperature. Okay, resistivity changes if you change the material, resistivity changes if you change the temperature. So this is also very important. Mention two factors on which resistivity of a conductor depends. Resistivity depends on material of the conductor, and it also depends on the temperature of the conductor. Okay, these two are the factors on which resistivity depends. So resistivity in terms of temperature can be written like this. Alpha is called temperature coefficient of resistance. If you write the same thing in terms of resistance, you get RT equals to R naught 1 plus alpha T minus T naught. Okay, this is also the formulas in terms of resistance. Okay, now these formulas are not relevant for your PU2, but it is relevant for KCET and any other exam that you might be writing. Now, if you are writing a KCET exam, then definitely you should obviously buy ABHYAS KCET 2026 test series, where you are getting 35 KCET tests. And also this year we are giving you absolutely free of cost last 10 years PYQ quiz. Okay, chapter wise last 10 years PYQ quiz. If you are studying this chapter, moving charges and magnetism, and after studying the chapter, suppose you want to practice the PYQs from this chapter, and you are wondering, okay, I will start in the morning and I will continue throughout the day, that much time you do not have. So what you have to do, you have to practice them within a given period of time. So if you open our app and if you go to this quiz, okay, it will give you a timer. Within that timer you have to finish last 10 years PYQ questions. Okay, so once you are done, you will check what are all the mistakes that you have made, what are all the correction that you need to do in your approach, how many of the previous year questions you are able to solve, okay, and why you are not able to solve. So these things are basically covered in our ABHYAS 2026 test ABHYAS test series. So here basically it's a test series where you are getting 35 tests. Okay, 35 tests. So if you want to practice more questions for your KCET preparation, then this is the ultimate way for you to get a good rank. And the price for everything is 1499, including biology. So biology is also included. So you don't need to worry. If you are only PCM student, you are thinking, okay, I don't want to use biology, then you can skip biology, right? Only thing you need to worry is physics, chemistry and maths. If you are someone who wants to appear for biosciences, then also you can consider, because biology is also included. And in everything is 1499, same as last year, and we are giving you KCET PYQ 10 years PYQ as absolutely free of cost, without any extra charge, right? So let us now continue with our discussion of the chapter, drift velocity. So what is drift velocity? Drift velocity is given by minus EE by m into tau. So when you are applying an electric field, the electron starts to accelerate, and because of the acceleration there, the electron gains a velocity, and that velocity is called drift velocity. Okay, and that velocity is actually constant. It only depends on electric field, the charge of electron, mass of electron, and relaxation time. Relaxation time is the time gap between two consecutive collisions. Okay, electrons are colliding with another electron, so the time gap between two consecutive collision is the drift velocity. Now current in terms of drift velocity is given as NEA VD. A is the area, VD is the drift velocity, and also you should remember, for a given conductor, if the current is flowing is uniform, then A VD is constant. Okay, so if area increases, drift velocity decreases. If area decreases, drift velocity increases. Now mobility, how fast an electron is moving, that is basically given by magnitude of drift velocity divided by electric field, and that is E tau by m. And conductivity is sigma equals to n e square tau by m. This derivation is important. If you want to practice it, you can check in our Brahmastra series. Now let's move on with limitations of Ohm's law. Ohm's law is not universal law. It has some limitations. What are the limitations? V ceases to be proportional to I at very high temperature and very low temperature. So if you increase the temperature very high, Ohm's law is no longer valid. Next, the relationship between V and I depends on the sign of V. So in case of semiconductors, the relationship between V and I depends on the sign. So if you are taking positive voltage, you are getting some result. If you are taking negative voltage, you are getting a different result that is not expected. So if ideal ohmic conductor will always give you a graph like this. So it is independent of the sign of the V. So if V is positive, you get a current in this direction. If V is negative, you are getting a current in the opposite direction. Okay, but if it depends, suppose you are getting a graph like this, for positive you are getting a graph like this, but in negative you are getting a graph like this, then definitely it is not a ohmic conductor. So sign of V is immaterial for Ohm's law. But so for semiconductors that is not valid. The relationship between V and I is not unique, that is there is more than one value of V for the same current. Okay, so if you are getting, say suppose you are getting a graph like this, you are getting a graph like this where for a same value of voltage, for same value of current, you are getting two different values of voltage. So V1, V2 gives you the same current, which is also violation of Ohm's law. Ohm's law says for each value of V, you are supposed to get a unique I. Okay, so that uniqueness is no longer valid. Example is a tunnel diode, gallium. There is one more semiconductor where this is not valid. So these are the cases where you don't get a unique relationship between V and I. Next, combination of resistances. Always I'm just giving you this is all everyone knows. Series combination, resistances gets added. In parallel combination, resistance get added, but reciprocally, and don't confuse the combination of resistance with combination of capacitances. Okay, combination of capacitance is exactly opposite to that. I have observed some students confuse between combination of resistances and combination of capacitances. Now if two resistors are in series parallel, if two resistances are in parallel, then you can use this shortcut formula as well. If more than two, then you have to take the longer formula. This is only valid for two parallel resistances. Now let's move on to electrical energy and power. Obviously, if current flows through a resistance, it spends energy, and that energy spent is basically given by the formula as H equals to vitamin VIT. Okay, so heat generated or energy generated by the resistance is given by VIT, voltage into current into time. Now power is energy absorbed per unit second. So in that case it is heat generated divided by time, which is given by Vodafone Idea or VI. Okay, and in terms of other formulas, I square R, V square by R. These formulas are important when solving some questions. Now let's move on to electric cells combination. This is very, very important. Derivations as well as numerical questions can come from this formula. Cells in series, easy. So cells in series, if all the cells are connected similarly, then you have to add them. If one of them is in reverse order, then that will be a negative sign. That will come up with a negative sign. So if everything is one after another. Now cells, why cells is different than normal battery? Because cells have a internal resistance as well. Okay, cells have internal resistance as well, so that internal resistance we take in series along with the battery. So this is the general symbol of cell. Ideal cell has zero resistance, but practical cells do have internal resistances. So this is say epsilon 1 R1, epsilon 2 R2, epsilon 3 R3. Now they are all connected in proper order. If one of them is reversed, then that will be negative. And in terms of resistances, total resistance should be just sum of all the resistances, right? In case of parallel combination, the equivalent EMF is given like this: epsilon divided by R divided by 1 upon R. Okay, so remember this as shortcut: sum of all epsilon I by Ri, okay, and then sum of 1 by Ri. Okay, so this is the shortcut formula. This is the easier formula to remember. If you try to memorize the formula given in your textbook, then you might be losing out and you might make mistakes. Okay, this is the easiest formula to remember in terms of practicality. Okay, and based on this formula we have seen derivations as well as numerical question. And in terms of equivalent resistance can be calculated like this. Now when you have found everything, equivalent EMF, equivalent resistance, then what is the current in the circuit? The current in the circuit is given by epsilon equivalent divided by external resistance plus R equivalent. Okay, this formula is valid for both cells in series and cells in parallel. Now Kirchhoff's rules, there are two Kirchhoff's rules. Junction rule, at any junction the sum of the currents entering the junction is equal to the sum of currents leaving the junction. So I1 plus I2 equals to I3 plus I4. So this is the direct consequence of conservation of charges. So if basically if you take the time constant, then charge is basically current times the time, right? Current multiplied by time gives you the charge. So what and a junction can be considered as an isolated system, and ideally the junction should have zero charge. So whatever charge is entering, the same amount of charge should leave, and if you make the time fixed, that also gives rise to the current as well. Now loop rule, algebraic sum of change in potential around any closed loop involving resistors and cells of the loop is zero. So if you take a loop where some resistances are there, some electric cell is there, okay, and if you take the loop, then if you add all the voltage drops across the circuit, then you should get that should be equals to zero, including cell. What I generally like to do, that you take all the voltage drops. So voltage drop means I into R. Okay, voltage drop means I into R. I passing through the resistance multiplied by the resistance value, that will give you the voltage drop across it, Ohm's law. And if you add all such IR, that should be equals to the EMF of the cell, provided you are going in the direction of the cell. Okay, cell has a positive and negative, so if the cell is trying to send the current in this direction, so if you are moving in this direction according to the sense of current, then IR should be equals to epsilon. Okay, and if you are going in the reverse direction, then it will be minus epsilon. Okay, that is the easier form to remember. This law is based on conservation of energy. So energy conserved in each resistance and the energy provided by the cell has to be constant, because energy cannot be created or destroyed. So that's why this is coming from the conservation of energy principle. Let's move on to the next part, last part, Wheatstone bridge. Wheatstone bridge is an application of Kirchhoff's law, where it says that if this condition is satisfied, P by Q is equal to R by S, then there is no current that is being passed through this galvanometer. That means the Wheatstone bridge is in balanced condition. Balanced condition means no current is passing through this galvanometer, and if no current passes through the galvanometer, then P divided by Q equals to R divided by S, or P divided by R equals to Q divided by S. That is also a balanced condition. And if the Wheatstone bridge is in balanced condition, you can simply remove this galvanometer and you can calculate the current in the circuit, you can calculate the voltage drop as well. Okay, if you want to look for unbalanced Wheatstone bridge, that I have performed and solved numerical questions in my live. You can check circuit theory live in our channel, where I have discussed multiple questions from this chapter, as well as unbalanced Wheatstone bridge, how to tackle unbalanced Wheatstone bridge in detail. If you still want a detailed video on how to solve unbalanced Wheatstone bridge, don't forget to mention that in the comment below. If I get 10 comments, I will try to take another live session where I'll be discussing unbalanced Wheatstone bridge again, okay, in a live video. So I wish you all the best for your upcoming PUC exam, and if you still have any doubts, any comments, don't forget to mention that in the comment below. I'll be back with a new chapter very soon. Till then, bye.